Hi everyone, welcome again to a new YouTube video, and in this time I would like to introduce you to the new format that we will use in the channel for few videos onwards, and this format is called speedrun networking. Okay, what is the intention of this type of format? Well, the intention is that we will have a set time for configuring some particular features in the network. So for example, in the left side of the screen, you see that we have a network infrastructure composed by 4 devices. This is a typical network infrastructure for service provider, right? And we will have 10 minutes to configure and provision a layer 3 VPN service. Okay, so we have P1 in the left side, P2 in the right side. The gigabit Ethernet 02 of each of them will be working as the services for layer 3 VPN. So we will put those interfaces in a BRF. And of course, we will need to build the layers that are needed for configuring a layer 3 VPN features. Those layers are first implementing ISIS, right? Later, encapsulation labeling protocol like MPLS LDP or segment routing. And on top of that, BGP. And on top of that, the service that will be the layer 3 VPN service. Okay. The challenge now is to have 10 minutes to configure all those layers. And I believe that this series of videos are quite useful for people that just want to know what is the way to configure specific technologies without going that much into the theory and explanations, but rather go into the CLI and configure the features right away. Okay, so that's the intention for this type of series videos. Let me know with a like if you would like to have some of them as well. We can produce for OSPF, for SRv6, for multicast, and of course it's a challenge, so we will try to provision all those protocols into the network infrastructure. Okay, so the challenge today is to have 10 minutes. So here I have my alarm, so here is 10 minutes, and we will count it out and start all over again. We don't have any feature configured now. As you can see in the screen, I deleted from all the devices. I only have the IP addressing, so let's get started, right? And also one note to add here, if we challenge ourselves in this manner, not necessarily with timers, but be constant in practicing, that's the way that we can stick the knowledge in our brain for all these CLIs and configurations commands that are needed to implement those features in the network. Okay, so okay, I'm starting the chronometer, so here we go. It will be fun and challenge. Okay, so now I am in P1. I don't have anything, so I will just configure router ISIS. I will use a net in the areas 1, right, with the name 1. The IS type level 2. Okay, segment routing MPLS, segment routing. Well, segment routing is already in there. Router ISIS 1, address family IPv4, segment routing MPLS, forwarding. MPLS, SR prefer. Okay. Now I need to configure the interface. In the case of P1 is 000 with enable address family, point to point. Actually, here, point to point is under the interface. Okay, so then 0001, address family IPv4, point to point. Okay. So now I have my ISIS configuration almost done. Of course, I need to add the loopback, address family IPv4, and here I need to add the prefix seat. It's actually under IPv4 prefix seat index 1 can be. Okay, perfect. So with that, I should already have all my configuration almost done. Segment routing, perfect. Then here I need to type segment routing just to make sure and commit. Okay, so here enables ISIS with all the interfaces under, and I put as well my loopback interface under, which I forgot before, and I put a prefix index of 1. Okay, perfect. So I will do the same in P1. Okay, here, router now the area 0000, 0011. I will put here SIS level type 2, address family IPv4, the MPLS forwarding, MPLS SR prefer, interface 001, point to point, interface 000. Point to point as well, the network type, the interface 003 as well, point to point, and the loopback 0. Here prefix index 11. Here is passive as well. Show configuration. Here I realized that I missed the metric style wide, so metric style wide, and the same in the other device. Okay, but this should be pretty easy to do. So router ISIS1, other family P4 unicast, metric style wild. Okay, perfect. So now we'll go to P1, P2. Okay, so router ISIS. I have 7 minutes, so net 001, 000, 000, 0012. Okay, ISIS network type level 2, family P4, then segment routing MPLS is our preferred. Interface giga 0002. Address family P4, point to point. Then I need to jump to the 0001. Address family P4, point to point, then to the 000. Okay. Network point to point as well. And then the loopback address family P4. Here passive. And also here I need to put the prefix index, which will be 22. Okay. Show configuration. Okay, I need to put the metric style wild as well. Perfect. So here we have all. I need to enable segment routing MPLS as well. Well, segment routing as well. Here I have 6 minutes. Okay, commit. Perfect. So I go to P2 as well. So in P2 I need to configure similar things. Router ISIS network 1, process 1, sorry. The area 1, 01, 000, 000, 002. Then here IS type level 2. Address family P4 unicast, MPLS, SR prefer. Oh, sorry, here I missed the metric style white, sorry. Then interface 001. 4, point to point network type, the 000 as well. It has to be with IPv4 and network type point to point. And last but not least, the loopback with address family IPv4 unicast. And then here the passive, and under the unicast prefix 6 index 2. Okay, perfect. So now I should see actually the ISIS sessions up and running. Perfect. So I can run a ping between 111 with 222. Perfect. Ping MPLS IPv4 111 source. Okay, I just want to make sure that I have all the labeling capabilities. Source loopback 222. Let me see. Perfect. So it works. Now I have ISIS in the underlay, and I have segment routing as well. If I do a trace route, for example, for the 111 source loopback 0 numeric, we see that the labeling to reach P1 from P2 actually is 16,001. Okay, now we need to build the service, which is basically the BRF. So here I will build the service, which is BRF Blue VPN. Okay, and here I will put address family P4. Sorry, under address family P4 I will put the route targets, which will be 100, 100. Import route target as well, 100, 100. Here import route target. Oh my god, I am very slow. Over here, under the gigabit 00, I will attach the Blue VPN, which is Blue VPN. Here the IP addressing, which will be 100.111, just to put a number. And here we'll build BGP. Okay, address family P4, address family VPN B4. Okay. Then neighbor 2222, remote IS 100, update source. This is to establish all the session towards router 2. Then next hop self, of course, and then the BRF Blue VPN. Okay, here I put the route extinguisher 100, 100, address family P4, and redistribute. Well, under address family P4 redistribute connected. Okay, so here if I go and check, basically I created the Blue VPN. I added the interface 002, the Blue VPN as well. I put the IP addressing, then I created BGP. I established a VPN before adjacency using the loopback 0 and remote IS 0 as well. Then I don't need to put anything, and then I created the Blue VPN. So far, so good. Perfect. So let me take a look what failed. We still have 3 minutes, so fatal condition, IPv4 must be removed. Blue VPN under. Okay. So here, okay, so 0002, I put wrongly. I will put back again, BRF blue VPN. This should be the right syntax. So 111.24, commit, perfect. So then I need to go to P2. I need to do exactly the same, BRF blue VPN, address one IPv4 unicast, export route targets. I have 2 minutes just to show you like that. So then 11 import route target. Route targets are very important to define the traffic engineering as well, so this is very important to have in mind. Gigabit 02 blue VPN, IP address 200.1.1.1. In this case I will put 200.1.1.1. Here no shoot. Router BGP 100, address family IPv4, address family VPN before, neighbor 1111 is to the IP address of PE1, remote address 100, update source loopback 0, address family VPN before, as well to enable the address family for passing the services, and then BRF blue VPN, here route distinguisher 100, enter under the address family and redistribute connect to redistribute the physical interface to be sent in the other direction, and from here this should be already good to go. Let's check what is failing. Okay, so I created, no, here there is nothing. I created the blue VPN with address family IPv4. Okay, so here I will put just as well default Giga 002, and then I will under 002 I will just put BRF blue VPN because it was not created before. 200.1.1.1.1 24. No shoot. Perfect. So now let's check the session. It's been forwarded. We are not sending anything yet. I am propagating my prefix 200 yet. So I don't see the other side, P1. 100. The prefix is still not been announced. It's because I didn't do no shoot probably. So let me take a look here, 100. Okay, perfect. So I see in P1 the prefix up to 2, and if I do ping, it works. I will stop the timer. It was with 9 seconds of almost in the time, in 10 minutes. But as you can see that the prefix already is being propagated between both sides, and the ping is working as well. So this was a rush, a lab, of course. I'm sorry if I wrote very bad the syntax. Now I have a keyword which is very small, and it's very hard to write it down, though I think we did it on time. So basically what I did, just to summarize to everyone, I created ISIS across all the routers. For example, in P2, I created ISIS. I defined basic things for ISIS that are needed for a service provider network, like the net, like metric style WALT, MPLSs are preferred, right? The prefix index, which is very important for segment routing. These two basically define the labeling layer for segment routing. Then the interfaces point to point, basically all the interfaces 01 and 02 in P2. The loopback 0 as well. So this is the needed for being under the process of ISIS. And at the end, this loopback will be used for establishing the BGP sessions. Like you see here, we have router BGP. I establish a BGP session towards P1 for passing the VPN prefix, right? So I defined remote IS 100, establish the session using the loopback 0. The VPN before address family is needed for this type of services, for layer 3 VPN. That's why I enabled the address family for that peering. Then I created also a VPN. So this is my service with parameters which are quite common and similar on the other side, which is 100.100. And then under router BGP, I define the services and I redistribute the connected interface, which is basically the IP address that I configure under the gigabit 002. Okay, so here I put the interface under a BRF with an IP address, and this IP address is the one that I redistribute in BGP. And this is why you have here me advertising this 200 prefix being the local one. Okay, this is basically the layers of feature that has been configured in P2. In P1, by other side, it was similar way. If we start with ISIS, for example, in ISIS, the net as well with the area ID and the identification, the metric style wall, that this is the one that I did a mistake at the beginning. But it's needed because it enables new capabilities as well for supporting prefixes in the routing table, and as well is needed for segment routing. Then segment routing MPLSs are preferred. The prefix index of 1 here in P2 was 2 under the loopback. Here I forgot probably to add passive command under the loopback and put router ISIS1 passive advertisement interface passive only, which basically only will advertise loopback zeros across the core, which is quite common for avoiding half prefix in every routing table. And then the interfaces of the physical interfaces of the P1. I didn't do the passive because I missed it, and it was not that much needed as well for the whole thing to work. Okay, but it's quite common to do. Just a high-level comment on that. And then the physical interface again. Okay, this is at the level of ISIS. At the level of BGP was quite similar to P2. So you define the neighbor 2222, and the remote IS is 100. The update source loopback 0 is the one that you will establish the TCP sessions for BGP. BPN-v4 is needed for exchanging the services, route target and route distinguisher across both PEs. Then the service as well with the route distinguisher, and redistribute connected, again, that is under the gigabit 002. Okay, this is the most configuration needed in the PE devices. In the provider ones, it's pretty much only ISIS. So here you have router ISIS, again the net ID with a unique value, the metric style wall, the segment routing SR prefer, the index as well for defining a label for the loopback. In this case I put passive here as well, and then the other physical interface in a point-to-point manner. P2 is basically similar, so most of the same. Whatever it changed is the 0012, which is the net ID. Okay, and the prefix index as well. The others are pretty similar. Here I didn't enable in some of the devices segment routing globally, because whenever you enable under ISIS, it will enable segment routing for that particular feature. If I enable segment routing for BGP, it will enable for that feature, so that's enough. If I want to have globally, then I should enable globally like that. It's best practice to enable globally as well. Here I have pretty few configuration I forgot to delete for traffic engineering, but this is another story. But the fact is that all the ping worked here. Again, I will ping to the other side, source 101, because P1 had 101.1.1.1, and P2 in the gigabit 02 has 200.1.1.1. So the ping work perfectly, which means that the service is up and running. And if we want to do additional verification, should be show ceph brf blue VPN 200.1.1.1. And here we see that the labels are imposed and are double, which is common in this type of deployments. Okay, it was quite fun and challenging. The most important from this video is for you to see what configuration is required to build this type of infrastructure, a layer 3 VPN with different layers, and of course to motivate you to challenge yourself on doing this type of exercise, because in this way is how you will master your skills for configuring, typing fast, which are quite needed for a CCIE lab, for example, in any type of technology. Okay, so I hope that this video was informative and that you enjoy it. Makes me, or seeing me running and troubleshooting a few things. So see you in the next one. Thank you very much.